So welcome back everyone to CFDE Pediatric Power Up. Today we are moving into day 4. And so again, as I've been kicking off to kind of recap where we've been. So we started with our kind of broad introduction to CFDE. And then we learned a little bit about the types of tools that you could use for bioinformatic analysis. And then we did a walkthrough yesterday of how do you use an existing tool on the Cavatica platform. So we went into the App Store and we found DESeq2, and I guess not the App Store, the app collection, and chose DESeq2 for our analysis. And then today we're kind of continuing getting slightly more and more complex. And so today, Sangeeta is going to lead us, and she's going to show us how she's building her own single-cell RNA-seq pipeline. And she's going to incorporate some data from the HubMap DCC as part of GTEx. So this is going to set us up. This is our last kind of walkthrough day, and it's going to set us up for Friday, which is really focused on how can we help you kind of take whatever you learned and move it to the next level. So that's where we're going next. And so we're so grateful to have Rowan back with us from Elsera. So she's here to help out in case things get a little hairy. But for now, I'm going to pass it to Sangeeta, who's going to lead us in our demo for today.
Thank you, David. Thank you for that introduction. And then thank you for a good recap of the entire training of what we've accomplished so far. As you said, things have gotten progressively more complex in the last 3 days. And today, it's going to get more complex. There will be potentially situations where things may or may not work. And while I have rehearsed everything and done everything ahead of time as well, it is possible that sometimes, some of the API connections might not work, or some of the uploads might not happen very quickly. Some of those things are expected today. And we'll also go through that process and learn how to handle that. But overall, what we're going to do today, I will go ahead and share my screen and talk about it. Yes, so overall, what we're going to do today is try to build a single-cell RNA-seq pipeline on Cavatica. And before we do that, we'll start with just a little bit of comparison of what a generic bulk-seq or whole genome, or in general RNA-seq data and data analysis pipeline is versus what a single-cell RNA-seq data is all about and how to analyze that. From that, we'll move on to the process of importing files from HubMap, which is one of the important and very vast resource within the CFDE umbrella that encompasses not just like imaging data, sequencing data, a lot of different varieties and types of data. So it's a very versatile resource to have handy and to be familiar with. So we'll take a look at that. And we'll talk about different ways of importing data, depending on the type and the source of that data from HubMap over to Cavatica. Some using a command line interface, some using a Cavatica for the inbuilt features. And then we'll go on to running an existing pipeline with some of that data. And moving on to using the Cavatica 7 Bridges command line interface setup, and using that to sort of create like an unpacking of existing workflow CWL file locally, so that we can edit it to customize it based on our requirements, and then deploy it back onto Cavatica so that we have a new app. So let's begin. As we saw yesterday, David talked to us about a lot of detail about DESeq2, what kind of data it uses, and how to process that data. Essentially, for a recap, RNA is extracted from like a population of cells for the RNA-seq experiments, for the RNA-seq analysis. And that essentially provides us with a snapshot of gene expression that is averaged across all cells in the sample. Now, this differs from single-cell RNA-seq because in that case, for single-cell RNA-seq, before sequencing, the RNA from all cells is pooled together. So there's like a single averaged expression profile for the entire population, the entire sample of different cells. This compares with RNA-seq generically, because RNA-seq is not efficiently able to capture the cellular heterogeneity within a population. So you cannot exactly identify if there are some cell types that are rare or like newer, or if there are like different subpopulations within a cell, within a group. That kind of information that cannot be extracted with a regular RNA-seq data extraction and analysis. Whereas single cell RNA-seq, because each cell is isolated and processed separately to generate its own expression profile, and then it is sequenced, it allows for examination of heterogeneity at the cellular level. And this is why we are able to, in case of single cell RNA-seq data, identify rare or newer cell types and basically understand the diversity within the cells across tissues or across populations, and characterize the different cell states, like where in the cell cycle, in like a healthy stage or like a disease state, or like the kind of transitions that happen over time within a cell. All those kind of heterogeneity can be captured with single cell RNA-seq data. The the general idea of extracting that data and analyzing that data for single cell versus bulk-seq or RNA-seq overall is that in case of RNA-seq, you start with like sequencing. So you have a fast queue, and then you align that to create a BAM file. And then you use that BAM file for some downstream pre-processing to generate using different softwares like FastQ or other softwares to also find out what kind of counts for the gene expressions can have been measured, and then visualize that. Um, and we also may need to normalize some of those counts depending on, you know, the kind of sources or the kind of analysis we're trying to run down the stream. And then once we have that normalized data, the analysis, the expression analysis on those differential genes, that is done using packages, some of them in R or in Python. For example, in R, my favorite, the most conveniently available is DESeq2, but there are also other packages out there. Compared to that, in case of single cell RNA-seq, we start with, as I said, we have RNA from all cells pooled together before sequencing. And that kind of information, that kind of data is stored in, and depending on whether that data stored, the object in which the data is stored, like the computational data object, if it's like processed or not, it can be captured in file formats like RDS or HDF5 or MTX or Loom or H5AD. Now, predominantly on HubMap, we will see that the single cell RNA-seq data is mostly found in this kind of file format. Oh, I did not turn this slide to the... Okay, now it's a bigger screen. You can all read through this. All right, so yes, so we'll have on HubMap, we have the data in the format of H5AD. We will, during the course of this session today, we will download that data, try to examine that, explore that file a little bit, and then upload it on Kavatica, attach it to an app, try to run the app, and see what happens as the app runs, and how, what kind of visualization, what kind of report it generates. And essentially in that whole process, we'll start with importing data. So this is like essentially the last slide. The rest of this entire session is going to be completely hands-on. So if you have your Kavatica open in front of you, and you have logged in, and you have any idea of like some data sets that you might want to use, maybe try to work with me alongside and try to do things on Kavatica along with me. It's possible that things may take more time, so we may not be able to cover everything today, which is why I have some data sets downloaded already, which I will show you how I work with them, uploading and attaching to an app and running an app and everything. But feel free to do things along with me, alongside. Let me go ahead and go to HubMap now. I have a few things open here. but let's start only with the home page right now. On the home page, we have a lot of these data sets. Now,
So
out of
Sangeeta,
go
I'm
on.
sorry to interrupt you. Right now, we can only see PowerPoint. We cannot see your browser.
Thank you for that, David. I will go ahead and share my entire screen. I think I was just sharing the slide deck earlier, but go ahead and share my entire screen. Saying earlier that we will need to shuffle a little bit between a browser and a terminal and our screen, our terminal. So let's do everything together and start with it. We are on the HubMap homepage. You can see here. And let's not specify what kind of organ system we want it from right now, but let's also try to at least find out if the data is protected or public and look at only the public data right now. And you see here, there's a bunch of these data sets that we can see here. Let's find some interesting data set. I will try to look for just a random data set and show you what kind of files it has. It has the expression file, the single cell expression file, which is readable with the and data Python package, which has essentially, it's analogous to the counts matrix that you see for RNA-seq kind of file. And HubMap also provides visualization of all these data sets for each of the data sets, and the metadata and a list of all the files it captures, all the different types of files, the fastqc, and the uh, and data kind of file, and the output, the visualizations that were created out of that, everything. And it allows like a transfer of that data using the something called Globus. I will not exactly work with Globus right now, but if you want to take a quick look at what Globus looks like, let's do that. Globus is another like file manager which allows you to use the Globus API to access and move data between the API endpoint clients. Right now, I'm going to not use HubMap for any kind of transfer of data, but I'm going to go to NCBI SRA. Let's open. Because NCBI SRA is also a more widely used data resource. And over here, we'll try to see if we can find some of the public data from HubMap here. And yes, we can. Out of this data, some is public, a lot of it is controlled. Let's look at some of the public data and see what we find. Here, we have found two of these results. Let's look at one of these. Okay, it's low. Okay, here. This is one of the data sets that we found. And now let's use this accession number. I'll tell you why we want to use this accession number, but let's use this expression, this accession number, and go back to NCBI SRA and now search for that accession number, using that accession number. The reason we are doing this is because with this accession number, we are now going to extract a file which has a list of all the accession numbers and metadata around it that we will use to import FASTQ data on Kavatica. See, this is what I meant. Things are going to be a little slow today because things take their own time. Okay, we have this now. And while this works in the background here, okay, it's ready. We are going to download the metadata file in just a few minutes. But before we do that, let's go to the Kavatika homepage. And create a project where we are going to run all of our analyses for today. I have my credentials saved. And I'm using the ERA Commons login ID to log into my Kavatika portal. And here, for now, we are going to create a new project. And you'll see what exactly we need to do. We essentially, all the users will have their own account reference, and we'll name this project as CFDE demo. And while we start, we also want to make sure that we assign a proper billing group, which is where your cloud credits will come from to use for data storage and compute power that we'll need in this project. And we'll also click on reuse, which is like a execution setting, because if you're trying to implement a workflow, execute a workflow, and if some of the results have been processed once and the overall process ends in failure, once you fix the bugs and you want to restart the process, it will let the compute power know that it doesn't have to use like 100% of the data again to process it. It can use the pre-processed data if it was successful, and then move on to processing just the rest of it. Also, in the advanced settings, I'm going to use this feature, allow network access, which will allow the users to work with other platforms which are interoperable with Kavatika, such as BBGAP or GTEx or something. If you have access to controlled data on any of those data sets, you might want to always remember to use this allow network access feature, and then create this project. Once you have a new project ready, you can choose to see if you want to edit the description of the project, if you have a certain goal in mind, or maybe you can do it at the end once you have done all the analysis and you know exactly what kind of data you've used and what kind of analysis you've performed and how you want to report that. You can use the description part to write that kind of documentation. And you can also work collaboratively with people in your group. I'm going to invite David here as a collaborator. And then I'm also going to invite Rowan here, because Rowan is the expert. And if we run into trouble, she's going to know a lot of what we can do. So I've added a few of my collaborators here, and they will have received notification that they've been added to a project. Once we have a project that is created and people who we are going to collaborate with, they've been added to the project, we want to go and see what kind of files we might want to work with, and then think about what kind of processing we want to do on those files. Right now, this files tab is empty. And while it's empty, let's go and find this metadata that we want to download. We had downloaded we are looking to download the accession list, the metadata for a certain accession number, which can be linked to some public data on HubMap. Let's download the metadata. And it's going to take just a couple of seconds. This won't be long. This is a smaller file, and it opens up here. And this is going to be a very long file, but for the purpose of just a demo, I'm going to make this file a lot shorter, because if we use a bigger file, the downstream process that I'm going to demonstrate is going to get just really, really long. So I will not have this data very long. This is the first data set, SRR. Let's just have 2 records. Anything beyond the 2 records, I'm going to delete. This is to make sure that in this session, we are able to see a successful run of an app that we will use on Kavatika. Okay. Okay. Now this file, we are going to save it because we'll need to upload it on Kavatika. We're going to call it, let's call it, let's use the accession number. And we have created a file now. We are going to go back to Kavatika and we are going to add this file here from our computer. Where do I see it? I just saved it, right? Yeah, here. I'm going to edit it, rename it, because it's missing the okay. Now we'll start this upload and it's going to be relatively quick. Great, it's done. Now that we have a file, I'll show you what to do with it. Now this is right now just some metadata around a certain accession number that is found within the SRA. So it has some attached sequence reads along with it. And to be able to find out what those sequence reads are, I'm going to use an app in Kavatika. And I'm going to search for that on Kavatika. I know that there's a certain app called SRA, download and set metadata. I'm going to copy this app into the new project that I created. It has here, you can edit the app URL that you want to use. So I'm going to remove this, and you can choose not to do anything with it, but I'm going to remove the version number of it just for demo purpose and create this app here. Now, when we go back to our projects, we will see in the apps tab that we have this here. We are going to try to run this. And as we run this, it will ask for us to attach a file, and we will attach a metadata file that we just created. Let's also look at the execution settings if there's anything we want to change here, but I think it's fine. We have the spot instances on, which it won't matter right now because we're not doing any like heavy processing here. And for the rest of the app settings, I don't think there's anything we need to change here. So I'm going to go ahead and click on run. Since we have only two SRR numbers here in the file that we attached, this might run in like 2 to 3 minutes. And that's like a safe time. It will probably only take like less than $1 to process that entire data. Right now it's queued and now it starts to run. And in the meantime, if you see here, from the apps, the process of running an app creates a task. In that task, you can choose to rename a task depending on what you're trying to achieve here. By default, it uses the app name and a timestamp of when you're trying to run the app. So let's remove the timestamp and use some other name just to see what happens. And you'll see that you can do that. This is a good way to track all the tasks that you work on, because sometimes you might want to run the same app multiple times when you attach different data sets on it. So you can use the task name to allow for those tags for the different data sets or the different purposes or the different downstream steps that you're going to use this task results for. I do have the next things that I can talk about while it runs. So let's do that. After this runs, we are going to go back to Hub Map and look for some more data. Let's go back to data sets. And again, and as I said earlier, the hub map is a very versatile resource because you have a lot of genomics and transcriptomics and proteomics, as you can see in this entire data set type. And you can filter it based on a lot of these different criteria, organs or analyte class or published data or the kind of processing that has been done. And as I was, and I will show you later as well, some of that data could be raw and some of that data could be processed. So in case of single cell RNA-seq, sometimes we can extract some raw expression data and sometimes we can extract processed data object, which could be like a AND data object that I was showing you earlier. Let's not use any filter right now over here. And then you can see the pipeline that has been used here for that kind of purpose. Let's just try to see what happens if we use RNA-seq, no specification for the organ. And of course, we want to make sure that we are using public data and no specification on the processed or raw kind of data category. And in general, all of these data is possibly going to be via the hub map or the Salmon pipeline. Salmon is for quantification of RNA-seq data. And let's see if we can find out assay modalities such as single cell here. And this brings us to a smaller subset of data. We have 264 results found. Out of this, let's randomly go on. Well, we're on the first page. This data set and download the expression file of that. And mind you, the download of this is going to take quite some time. So I will click on download here for this particular file. But depending on how much time it takes, I may or may not be able to use this file. But I have some data sets that I downloaded earlier that I will use for demonstrating what happens next. Let's go and see what's happening on Kavatka, whether we finished running this or not. How long has it been running? Okay, this was just completed. Now let's look at this task and see what has happened inside and what kind of output it has generated. It has generated a log file and a metadata file and some reads for that. These are the fast few reads, which we can use for any kind of downstream RNA differential expression analysis kind of processing or any kind of other variant calling or any other purposes. And these output files will also go here, just like we had those files here. So this is the file that we uploaded. Sorry, this is the file that we uploaded. And the other files were generated as output of the app that we just ran, and we had renamed the task for it. Now, if you wanted to add more files with it, we have seen how we can directly import data from the repositories that Kavatika can interact with, is interoperable with, such as SRA. And we are also seeing some data on GTEx yesterday, which David imported to Kavatika. Other than that format, we can also bring data over to Kavatika from AWS buckets. B3B Open Target is an AWS bucket that I have access to. So I know that it can come from here, but I don't have to bring over any data from that right now. And we can also bring some of the public reference files, as David mentioned yesterday. And these could be like the GTF files or, the reference genomes essentially. So you have a lot of these ensemble genome references here. And the GRCH 3738, all versions of that. But we don't need any of those right now. But this was just a demo to show that we can bring over some of the public data without having to download them locally or using an FTP or anything. Let's go back to our project and to the file section. You see, we are going to, this is still downloading. and it's going to take a long time to download this. So I'm going to go to another file that I have downloaded. I have a lot of these data sets that I've downloaded earlier. These data sets, the H5AD files, those I downloaded from HubMap earlier. And I'm going to use a Kavatica CLI, 7-digit CLI, to use these files and upload them on Kavatica. Let me show you how to do that. And I have this this cheat sheet that I've written for myself to for me to know how to get started. For Kavatica, we want to, and we can also, let me share a link of the documentation here. You can all look through this as well, but I have done it at my end earlier. That's how I know what I'm going to do. I have already installed SB pack at my end, which allows me to edit, unpack, and redeploy some apps on Kavatica. I've also created, if you're familiar with AWS S3 buckets or GC, Google Cloud, you might know that you have to create a profile with credentials locally to be able to access those data volumes. It's a similar case with Kavatica. We have to create a credentials file locally and use a Kavatica API endpoint and attach an authorization token for a developer to be able to work with the Kavatica API. But once it's all set and you have the command line set up, we can work with commands as simple as SB is short for 7 bridges, upload, start, the file name that you want to upload, and the destination, which would have to be the username, the owner, and the project name. Now let's find the project name. I have used a different project name over there, but if you see here, you want to get the entire project name here. This is my project name. So I'm going to create a new command here. And I'm going to use my username because I'm going to attach and upload a file to my project. This is the project name. And I'm going to also attach a tag to that file name so that I know what purpose I'm attaching this file for. Now let's get the entire path for the file. I'm going to use my terminal to get the exact path. Oh, what's happening? Yeah. It's similar to this. So I'm going to use this. It has a space in the middle. So I'm going to use this entire path here. You see. Followed by this path, followed by the file name that I'm trying to upload. And let's also rename this to remove the dots and replace them with underscore. Okay. This is just to avoid any confusion about what an extension is versus, that's not, sorry, I hit copy. Now this is the file name. So essentially we've created a command where we are saying we're invoking the Seven Bridges CLI to pick up a certain file from the local computer and upload it on Kavatica. Now let's go back to the command line. And use this command to see if the upload goes successfully. Oh, I missed this tag. The keyword tag is missing here. And the power up demo is the tag, the value of the tag. Let's see what happens. Yes, this is not found because in Kavatica, on Kavatica, the project name, as you see here, it does not allow capital letters. So I'm going to change it to small letters and then try again. There's one more capital letter. Now, what was that? And I've done this earlier. Ravan, please feel free to jump in if you see anything that I'm doing wrong. I know that the same command worked earlier, but I wanted to demo this. Or I can just bring over a file from the other project that I created earlier.
Yep, I'm just trying to see what's going on. Destination not found. Upload start. Are you sure you spelled the name of the project correctly and everything's capitalized correctly? Oftentimes I try to like do the tab so it auto completes just to make sure.
The project name is on Kavatica. So, I mean, I copied it from here and I know that Kavatica does not, when I try to work with projects, it does not allow me to use capital letters. That's why I just had to use all small case.
Okay.
Like you see here, this is the project name earlier, but it does not allow capital letter. And I know that the rest of these, they have worked.
Okay.
With the command, I don't think anything is primarily wrong here. And it says destination not found. So nothing with the source is wrong. It's the destination.
Yeah, it's specifically the destination. So just to be safe, what you could do is SB and then space L, or trying to remember what the actual command is, but there's an option to list projects, and that will allow you to get the full name of the project as it's written, just in case.
Yeah, I had that earlier. I ran all that earlier to just get a list of all the projects that I have access to. And okay, this is just output. I did not leave that command here. These are just the
I'm trying to look it up just to make sure. That's usually what I do just to make sure that it's exactly as written.
Absolutely. I did that too. I just didn't save the command.
Yeah. I'm trying to remember where this command is listed.
That's okay. While we figure that out, I do have some files that I attach to a different project, and it's possible to just copy some of that data files over to a newer project. So I'm going to go to a different project and look at the files that it has. And I'm going to just search for files that have H5AD extensions. Okay. And this, for example, is one of the files which I can copy to the Power Up demo. It doesn't have to be a tag. This is just for, and it will show you what the activity center processing of what's happening in the back end. And now it looks like this has been copied. So let's go over to this and see if it was copied, and it looks like it has. And it comes with the same tag that I used when I uploaded it from command line locally over to that project earlier. So it has the same tag and everything has been copied here. This is an H5AD file right now. And the workflow that I want to use it with later I am also going to copy that workflow, which takes a single cell object as an input. Yeah, I had used both of these projects earlier. So let's just see. Let's just copy this project, this workflow into our existing project. Once you have that, you can look at the overall workflow of what's happening inside this app. You can read a little bit of description about what this app is going to do, what kind of input it's going to need, in what format, and if the documentation does not exist as descriptively, you can also look at these parameters here, where you will see what are the kinds of input, what are the kind of app settings it already has, and what are the kinds of outputs it will come up with. It's going to essentially need an input, which is going to be gene cell count matrix, which is essentially like a in case of single cell data, this is going to be like the equivalent of the count matrix essentially. And here it will have to be something in the, as we saw earlier, as we saw here, it needs to be in a certain format. That format could be R data or RDS or GZ or MTX. Now, the file that we downloaded from HubMap, as you saw, all these files are in the H580 format. But R allows us to, there are libraries, there are packages that allow us to convert these file formats like interchangeably. So I have a script which we can use either here in the data studio, and again, firing up a data studio and running that script everywhere. Again, I'm going to stop this download right now because we won't need that. I have another file that we're working with. So yeah, I was saying that we are going to use a certain R script. It's not, it doesn't have to be a very big script, it's just some basic commands, but we'll use that to convert the H580 file into a file format that's compatible with this app. It's called RDS. Let me show you the script. I have the script for where I was doing all my exploratory data analysis and installing all the packages and everything. The package that will do this conversion is called SCEasy. The data object that we are working with, the H580, is compatible, as we read earlier on HubMap, that it can be read by the and data Python package. There's also our equivalent of that and data, which I've downloaded here, invoked here in my script. And while I was doing some testing, I was also using the Surat package to create a Surat object as well. Let me find the path for one of these files. Let's say this one. Okay. 842 here. And I have renamed this to have underscores now. So let's get the new name here and attach it here. Replace the file name and use the read H580 function to read a certain file. Okay, now the data has been read. Let's also see what kind of file type okay, I don't remember how to clear the console here, but never mind. Let's look at the kind of object this newly read file has. As you can see here, this is an and data object. As you see here, it has a lot of these kind of slots essentially, which has these chunked X and X kind of things. Let's also view some of the elements, some of the data entities captured inside this data object. We'll start with the $sign to see what kind of things it has. And one of the things that I know this data object has is observations and the functions that can apply to. Let's look at X. Now, X is going to give us a list of, let's show up, list of genes and their counts. So this is essentially the counts data, the counts data, the counts matrix that we're looking for to process downstream in our pipeline on Kavatica. And there's also the list of genes that you can extract from that same data object. This is it. And this has like the gene name and its UCO symbol, NSG symbol here. We don't, I should have extracted like just 5, 10 of them, but somehow, yeah, I have the entire set of rows here, but we don't need to look at all of that. But what we're going to do is use this data object to do some exploratory data analysis, and then use the same file reference to pass to the SCEZ convert format function and create a Surat object of it, which has the RDS format, which the app that we were talking about is able to take. So let's use this file reference here and attach it here and run this and see what happens. X are the counts as we saw earlier. The bigger the file, the longer it takes, but it still won't take very long. I've tried this earlier and it only takes like less than a minute or something. Yeah, it's ready. So now this has created a new data object, which is of class Surat, which is basically a Surat data object. It has 60,000, over 60,000 features. Features are essentially genes. And you can also see how many samples it has data across. So it has basically 2 layers present, the counts and the data that we're going to work with. And now that we have the RDS object, let's also try and just read the RDS object, right? We have created, in that same location, we have created a file. Uh-oh, I overwrote a different file. I should have used this here. Yeah, mistakes happen. So I'm going to rerun this because I don't want to use a improperly overwritten RDS object. I will rerun this. And then I will use this RDS file for some additional data exploration. It should take, yeah, it's ready. Yeah. So now we'll use another read RDS function, which is available in R, and read in this object. And that was quick. The object is ready here. The read RDS object is ready here. If you see, it's a Surat object as you see here. And there's multiple ways to confirm what kind of data object it is. You can use the string RDS object kind of command here, and you'll see the same output on the command line. Or if you're using a certain R environment, you can also look at this kind of display here of what that data object is all about. I have a lot of messages in the chat. Let me quickly take a look at that. Can Surat objects be saved as bitpacked sketches nowadays? Yeah, I think it probably does how the app is. Absolutely, yes. These apps that I'm trying to demonstrate here, they have been written a little while ago. So yes, there are newer updates available within the packages that we're using right now, or some other features that, there are some more recent packages available out there. You can just use DevTools if they're not available on CRAN yet, or like since I'm using R primarily, but there are also other Python packages to process these kind of data objects. But yes, you're right. There's a variety of options for the steps for processing these kind of files. But for now, we have this RDS object that we've created. The file exists, and we're going to find a way to upload this file on the Kavatika project. Let's see if this part is now successful. We have the file name over here. And we'll just confirm that it exists here. Yes, we have created this new file here, the 255 file here. We have recently created that. And we are going to use our, where's the Sublime text? Yeah, here. We are going to use the same kind of command that we created earlier to upload it. SB upload start. And the file exists here. I will just use the file name here, and the rest I will copy from here. And then use the destination. And let's also use the tag. And let's see if we are able to successfully run this command. Earlier on the shell, it did not work, but let's see if it works now. But even if it does not work, I have used the same command earlier and have uploaded an RDS file. But Rowan, please feel free to see and let me know if there's anything wrong you see with this upload process. The file name is there. I don't see any extra spaces. The destination is there, the project name and the username is there, and the tag is there. Let's see what happens. Destination not found.
So truly, it just has to do with the name of the project. I'm thinking, again, can you just type real quick SB space projects and then space list?
Just this?
I think that's correct. It's either project or projects. And then that will give you the full names of all of your projects. I'm just trying to see what the difference is.
Oh, it's a hyphen and not an underscore. It does
So
not.
that's the easiest way I do it, is just double check.
Great.
Because I don't know, I can never remember how it ends up displaying. So
thank you. Thank you.
No
so
problem.
now I'm going to change this underscore to a hyphen.
You can also do something where you just type your username and then / and then tab, or type in like C and then tab, and it will auto-complete the name so that you don't have to remember how to spell everything all the time. This is handy with long file names or other issues.
Absolutely, yes. And so for all the folks here, this is going to be relatively quick. I've done this earlier. It's going to be relatively quick. But as you see here, there are some, unknowns that come every now and then when you try to do something new with Kavatika, because there are some rules that the platform follows, like it doesn't take underscores in the project name. You can see that on the UI, but on the command line, it does not work with underscores. It requires hyphens. So it's a good practice to make sure that you have a project name that's intuitive enough so that you don't get confused between CLI and the UI and everything. But now that one of the uploads has worked, let's scroll up a little bit and also upload the H5AD file that we were trying to work with earlier. This is the file, and let's upload this one as well. I'm sure this will be quick, and then we'll see all of these will show up in our files tab on the project that we were working on. And thank you, Ruan. That was perfect.
No problem.
It'll be quick. This is faster, and that's the thing. When we're working with larger files, files that are heavy, that are heavy in size, it's a better idea to not use like the UI to just click and drop and drag and drop kind of upload. It's better to use a CLI approach to do this kind of heavy lifting. And that's what I'm trying to show here. Although there are some files that we can directly bring over to Kavatika, there are some other files that we may also want to work with if we have them locally, or if we have if we're working with other collaborators and they haven't hosted it on a public platform yet, but we have some local files and we want to work with them. There are many ways we can use to just bring all the necessary data over to our project on Kavatica. And this is taking slightly longer. This is a bigger file, but let's go to Kavatica here and go back to the Files tab, because the RDS file, that was a successful upload. So we'll see that here. See, this is the RDS file that we just uploaded. Yep, and we see that the timestamps are here. These are the fast queues that we created earlier, and these are also the results from a previous run of something that we're working on. Now, RDS is one file that we will be able to, and you see here the tag that we attached. Now let's go back to the apps and try to attach to this app the RDS file, because as we read from the documentation, it can take the RDS file. RDS has the gene counts, as we saw from that data exploration that we did locally, and it automatically looks for files that are compatible with that parameter that we're trying to fill up. So it only shows us this RDS file here, which we will attach. There are all these editable parameters here, but I don't want to edit any of them. I will just not do anything with them. And Rowan, if you're familiar with this app and you have any quick tips for me, feel free to let me know. And I will also just update this task name here.
So I was trying to run this app in the background also. So we'll see if this runs successfully or smoothly. But I think there's a server issue happening with maybe Ensemble or something, because I was getting some strange errors as well.
I think
I'm
that's
gonna keep trying to test it, but it keeps saying it's failing to fetch like the names of things, or
yes,
I don't know.
yes.
I will let you know, but we can troubleshoot and figure something out.
Absolutely. So if it does not work, we know what kind of errors we might be faced with when something doesn't work. It's not just that our files are wrong or anything, but when we're trying to work with other platforms and other public data sets, things can happen at times. But yeah, that's a great way. We'll find out what happens next. And once this is done, and it's 11 o'clock, so if you all want to take like a few minutes of break, because I know that this is going to take, if it fails, it will take about 3 minutes. If it runs, it will take a little longer. Let's find out what happened to the task that we had initiated before we went on break. I will go ahead and share my screen again. And I will go to the Kavatica homepage. And apparently, as you see here, this task has failed. Let me just refresh it so you can all see what I see here. It has taken 2 minutes of time and a cent in processing cost, but it has failed. What do we do next? Let's try to find out what the error might be and understand where that originates from. If we look at the task in general, we'll see the error message highlighted here. And here it says that it failed with the exit code 1, which is not enough information for me. But we also have some additional information about the statistics and the logs at the back, at the behind the screen version of the app and how it is processed. So the part that was completed was the part where it was loading the Docker, and then over here, this is where it failed. Let's see what happened. We'll look at the logs and try to look at the error log to see if there's any specific indication on what happened. We see that it was trying to like attach and load a lot of these packages which the app was invoking. And toward the end, it says error in if the input type is single cell experiment, the argument is of length 0. Now we know that what we attached was a legit Sarad object. It has enough single cell data. We have the features, we have the counts and everything. We have attached everything here. And yeah, sometimes we don't know what exactly went wrong with the app. So what we can do here is reach out to the folks at Valsera using a ticket to let them know that something is wrong in our app by clicking get support. And here, when we do this, they will be able to get access to the entire process, the entire app, the project that we're working with right now. So they can look into everything under the hood and see what happened and help us find out and fix it. So Rowan, I'm going to open a ticket here, just FYI.
Yeah, smart.
It's good to make the message as intuitive as you can. And we've sent the message and opened the ticket. So Rowan and her colleagues will be able to receive these kind of messages and tickets at the back end, and they will be able to work on this and then reach back out to the person. They obviously, because I have a username and an account here, they also have access to my email address. So when they work on this ticket, I will receive email messages, email notification about what's happening at the under the hood. But now that we have looked at, how to copy an app, attach data, try to see if it runs, if there's an error, deal with the error, or reach out to the support team to see what they can do. The next thing I'm going to show you is to see, basically find out how to edit an app. If we eventually want to be able to create an entirely new app, and of course you can, we would use we can use something called the CWL editor. If we go to this place, edit here, it can open up a screen, a visual editor of the app, and we can use this space to edit things here on the UI. And we'll see things here, and we can edit values here, descriptions here, everything over here. But if we are trying to do something completely from scratch and create an entirely new workflow using Visual Editor, and if you're not familiar with it, it becomes a little tricky. So the cheat method that I found works for me is to be able to just use this existing CWL code locally and attach like edit the descriptions everywhere, or remove or replace the R scripts that might be attached here, or the shell scripts that might be attached here locally. So what I'm going to do is use a command line method. Sorry, I will go to apps here. This is the list of apps here. I'm going to use a command line method to use an existing app on Kavatika and download it locally. Let me find that command. I have my local Seven Bridges credentials profile and everything set up. And I'm going to use the existing project, the CWL for an existing project, and unpack it. So for this, as you see here, it had the edit. This is the code. And I have the label and everything and the app name and everything. But let's also try to get the app name. Ravan, can you help me find out the command to get the list of apps inside a project so that I can use that exact app name on this command here to pull the
Let me see.
file.
Hold on 1 second. I'm trying
But
to
in
find
general,
out.
the syntax, thank you, Ravan. But in general, the syntax is that we want to use the authorized profile, the username, the project name. Like in my case, it's the the profile that I have named locally for with my credentials. It's called Kavatika. My username is Shukla S1, and I can use a certain kind of project name here and the app name here with the with the option of unpack. This is going to create a local copy of that entire CWL file for that app locally. But let's wait for Rowan to help with the.
Sorry, I'm typing it in the chat.
Okay.
Okay. It should be pretty similar. It's SB, and then I can read it out loud to you if you need to. Also, it doesn't matter.
The copy. I have a lot on my screen right now. I will close this, go back to my command line, use this command. The project is called, do I need the username as well?
I would keep it just to be safe. Let's find out. I can't ever remember how they changed this. They updated it, I think, early or late last year, and they changed the formatting. So,
sure. All right. So this, let's see if this works. And the intention of doing this is to get the exact name of the workflow. Okay. This is giving me a list of all the workflows that I have access to, that have been added to, but not just the project. How do I limit this to the project that I'm working with? But anyway, I mean, I can get the information, so I don't have to worry about the rest of it, but.
That should be just for that one project. Yeah, you can list from that very specified project just by doing the hyphen project and then list the name of the project. But if that looks like too much, maybe we can try removing the username and see if that does anything.
Yeah, that's a good idea.
Just to be safe, I don't know.
Yeah.
Is that still a list of everything?
Yes, still everything. Never mind, I'll just copy the, oh my God, I'm scrolling so much. Okay. So we're looking at this multi-sample Surat, this particular app name here. I think this is what I'll copy. And the rest is the name of the app as it appears on the UI inside the project. So I'm going to take this data and use that app name to write a new command. It starts with invoking the 7 bridges command line, and we'll do an SB pull with my Vatica profile with my username Shukla S1 and the name of the project that we're working with, which is the one that we talked about here. Essentially, we'll just use this here. This is the workflow name, and we are going to pass it to the location that we're working with earlier here. Base module, and we'll call the file name. Do I need to give it a file name, or can it intuitively take the name of the file, the CWL file from the workflow?
I think it should be able to pull up the CWL file name if you just tab, or maybe not.
Yeah, and unpack is the option. So I'm going to use, first of all, invoke SB pack h here. And then use the SB pull command to unpack the workflow locally. The S is missing, it's only B pool. Let's fix that. I think it's good. Let's hit enter and see what happens. This is a directory. And I think we'll have to specify the name of the file. Let's call it local sample rad.cwl, and into that file, let's unpack this. It worked, see? So cool. Now let's go ahead and find a better editor to see what that CWL file looks like. So we're going to use this file here, and I'm going to open the CWL, this CWL in do I see Sublime here? Yes, Sublime. It just has a better UI. So let's look at this. This is what the entire CWL looks like. And locally, it's easier for us as bioinformatician developers to use this kind of editor to update everything in it. And by everything, I mean, it could have like R scripts, it could have shell scripts linked to it, and we can replace, edit parameters as needed here. So let's see. First of all, let's create a new, let's use this CWL to create, let's save this as a test CWL that we're going to upload again into a new app. Test CWL, test multiple Seurat CWL. Let's save this as this. And then we'll change the label just so that we know that this is the test that we're working with. Let's, just for the fun of it, remove all sorts of documentation here, because we want to see if we are able to create a new app. So we'll just try to make some changes to the CWL file as proof of concept that we are able to do this. Okay, here. This is where it ends. I'm going to remove this much in the documentation and then leave the rest of this input data and everything as is. And see, let's find something .r. It is only looking for .r. There's only one R. Let's look for .sh. Sorry. And look for any kind of shell scripts that are attached here. And see if we can like change any default parameters, edit any parameters, and replace some of the content. Just for the heck of it, let's just change this label into test, differential expression test, and then we'll see if when we deploy the app, we are able to find this update. See here, this is like the call to the existing CWL or multiple simple sample Seurat CWL steps loading, and some other CWLs that works with. Okay, let's stick to these updates right now and close this file and use another command to publish a new workflow with this CWF file. Let's use this a new project name. Let's use a new test app is the workflow name, and we'll use the file that we created. Here. And as we upload this, as we deploy this, let's also make sure that we are in that same directory. So we are able to use that path. And I think we are all set with this new command. Yeah. Let's see what happens. This essentially is an attempt to deploy the app that we could build from the CWL file that we have locally. It should have given me some messages of uploading. Yes, I think I know what the problem is. The path here that I'm using, it has an extra double quote here. Incorrect path for app ID. But at least it was invoking the SB pack. So let's see how to fix that path for app ID. Okay, here the project name is not appropriate, I think. And let's go back here. And this is, for example, this was going to be, this would have to be the demo, and then the name of the app. So we have to have this path and then the app name. So we have the username, the project name, and the app name. Now, does it matter to have capital or small letters here? Let's find out.
I don't think it should, but we can see.
I guess it should not. And lo and behold, we have deployed an app on our Kapatica project. Let's go look at that. And I was logged out, so let's log in again. Woohoo! You see this? We published an app. Let's look into this app and look at the hopefully missing documentation. A lot of it is still there. What happened? Why wasn't the documentation missing? Let's check our file. Oh, it's still there. Did I not save it? Okay. Let's remove only a part of it, so we know and save it and use the same command to republish the app and see what happens. Now that it works, we know we're not doing anything wrong. Malinformed file. While parsing, but not found so that the input is not required. Yeah, something was different with this. I tried to remove some documentation. It did not work. I can maybe just re-download the file, but the whole point is we were still able to create a new app here, and we were able to publish that. And that will be the whole process of, trying to develop new scripts and attach it to this source. And as you see here, this is revision 0. This is the first time we're doing it. We could edit it here, for example, and here is the entire documentation. So let's see if I can completely delete this documentation from here. Documentation is empty, and I can save and run. And that would create an edited version of it. We just wanted to save it, not run it. But if you open it again, this is revision 1 because we made some changes to the CWL code inside it, which is great. So essentially, so far what we've accomplished is we've tried to import SRA data that is available in HubMap and import it over to Kavatica and use that SRA to create, to extract the fast queues attached with it. We tried to run that app, which successfully extracted the fast queues. We also captured some of the single-seq RNA sequencing, single-cell RNA-seq data from HubMap. We downloaded the HDF H580 file, which is of the which is a data object of the and data Python package. We used R to convert the H580 format to an RDS format, which could be attached to an existing app on Kavatica. We tried to run that app. We made an attempt to understand what kind of error it has and how it can be fixed potentially, or reach out to support with Wilsera folks. And then we downloaded that entire CWL file using the 7bridges CLI locally. And we attempted to edit that CLI and also deploy a brand new app on Kavatica within the same project. Now, this is a lot of steps that we've covered. And if you were to try the same steps with the data that is more relevant to you, I'm sure you will run into issues the first few times. But I think it would be beneficial for you to take that time, even if you run into issues, and work through them. Because once you have done that, by the end of it, you'll know that you can collaboratively work within your team to use a lot of the publicly available data or some proprietary data that you might work with. Bring that over to a cloud workspace where you don't have to worry so much about the architecture for the data storage or the compute power, the resources that you have to use to accomplish any kind of bioinformatics pipeline implementation and processing. And you don't have to worry about how you will continually manage the evolution for that app. You could attach scripts that you have on your GitHub to the CWL file on the individual components of that workflow, as you see the nodes over here. You could attach individual scripts in GitHub if you have any to these kind of steps in the CWL workflow. Let's see here, for example. Does it attach? When you go to edit, visual editor, see here, you have a lot of these parameters that it expects that you can work with. And you can also work with these data sets here, and you can look at the app info, the description for each of these, inputs for each of these, define whether or not you want some default input, like mandatory input, or have like default values for input that are not already passed on. And you can also attach scripts that you need. For example, here, run condition, you can like set an expression that this could have like expressions like where a value, so a certain value needs to be above a threshold or something, anything that you want. And you can use this kind of parameters to define what kind of input type you want to work with. Essentially, you can edit your parameters, edit your files that you want to work with, attach new files. So if you are using a code repository like GitHub, every time you update your GitHub, you can just deploy your package to use that GitHub link. And it's very simple. It's as simple as this. For example, you just use the path for your GitHub script when you deploy it to a certain project, certain users, certain project, certain app. That's simple. So if you wanted to work with custom scripts, that's doable. If you wanted to work with an existing app in Kavatika but customize it for your needs, that's doable. So there's a lot of things that you can accomplish with having this kind of collaborative cloud workspace at your disposal, especially with the cloud credits that you have. And we do have some 20 minutes left in the session. So if you have any questions, please feel free to talk to us, reach out. We have Rowan here from Vasera. So if you have specific platform related questions, I'm sure she will have an answer for you all. If not, she'll still have a team who can get back to you.
While it's quiet, I'm going to jump in real quick and just thank you guys for having me. I'm going to share some resources, I guess, in the chat is the best way. We do have onboarding videos for Kavatika, as well as some of our other platforms sponsored by different NIH organizations. So the Kavatika one, starts pretty simple with just really getting started on the platform. I'm sure you've seen it at this point, whatever it is, but they're really great for reference. So I'm going to just drop that in the chat. And then we have not part 2 for Kavatika yet, but we have part 2 for the Cancer Genomic Cloud, which is sponsored by the NCI. And it's very similar how the platforms work. So on that playlist, we have things like how to build apps and how to interact with like workflows if you want to edit them further. So I'm happy to share that as well.